Okay, so today we're going to look at the Newton-Rhapson method for locating roots, and this is going to be a final topic on numerical methods, and then I think we've got some work to do on vectors, and that's all I'm going to cover on the specification. I haven't covered every little detail, but pretty much on that playlist you'll find the whole specification. So be sure to check that out before your exams. Okay, so we've got, it's an iterative method, so the formula is that xn plus 1 is determined by xn minus f of xn over f dash of xn, so the derivative of f of xn, where f is the function that we're trying to locate the roots of. Okay, so we're trying to solve for f of x is equal to 0, and when we take a guess at our initial x0, we want to try pick something that's kind of near to where we think the root's going to be, so that we don't take forever to get there. And then what we do is we keep going until our xn's become extremely close to our xn plus 1s, because at that point, if we've repeated maybe 3 times and we keep getting a value that's the same to 3 or 4 decimal places, that's a pretty good guess at the root. Okay, and then of course with calculator technology now you can check these roots almost immediately by just typing the polynomial or whatever into your calculator. So the best way to get through to explore this method is with an example. So if f of x is equal to x cubed minus x minus 1, we're looking to find one of the roots, and if we use the sign test we can see that f of 1 is equal to minus 1, which is less than 0, and f of 2 is equal to 5, which is greater than 0, and this is a continuous function, so by the sign test there must be a root between 1 and 2. So we might as well take our first guess as 1. Okay, so we're going to say x0 is equal to 1, and then we're just going to find x1, and that's equal to 1 minus 1 cubed minus 1 minus 1 over, and differentiating this we get 3x squared minus 1. So we get 3 times 1 squared minus 1, that's equal to 1.5. And then in your calculator this will already be saved into ants as soon as you do this. So after that's happened, okay, so you've typed that in on your calculator and it's came out as 1.5. Of course you can do this calculation in your head, but do it on your calculator for this reason. It's so that when we want to find x2 now, we can just type into our calculator. Okay, so this is xn, these are in the brackets all xn terms, so we just type in ants minus ants cubed minus ants minus 1 3ans right minus 1, and then we just keep pressing the equal sign until we come out with maybe three values in a row that all have the same decimal places, and I end up with 1.324, and that's going to be my guess, 4 significant figures, 3 decimal places. And if you check on your calculator, that is using the root finder function. If you have got a graphical calculator, which you should, I think, then you'll see that this is the root to 3 decimal places. In terms of marks in the exam, will you get away with just typing it in the calculator? Yes, as long as you use the calculator. Maybe I think this appeared after term 5 or something, and then you just write out the formula for x2, for x3, for x4 and so on, but the calculation's all been done on your calculator, and then you know how far you have to go and such. So that's a useful little tip, save you a bit of time. Okay, so remember this here, but also remember, don't just do the whole iterative process on your calculator and not write anything down, or you will be very limited in your marks. So make sure you're writing out at least the iterative formula and at least probably the first three terms, so x0, x1, x2, and yeah, possibly x3 and so on as well. Okay, so thank you very much for watching this video. If you did find it useful, please like the video, it really helps the channel. After we finish with the A-level maths and further maths specification, we're looking to do something a little bit different with the channel, still maths related content as always. So yeah, hopefully you'll stay tuned for that. Thanks for watching, and I hope to see you in the next one.